Hello, and welcome to Studio 6, Team G's final assessment video for ES 1050 Project 3. For our final project, our group was tasked with designing a wheelchair-accessible kayak seat for a Riot 12 Enduro kayak for Abilities in Motion London.
Due to the shape of a kayak, one has to support their full body weight to enter or exit the cockpit. This is a challenge for individuals who lack the ability to move their legs.
Also, many wheelchair-bound people lack the typical core strength of an able-bodied person because they do not develop this strength through walking. As a result, additional support is often needed for these individuals to row comfortably from a seated position.
Many wheelchair-bound people do not have sensation in their legs, which means if they are sitting on an uncomfortable surface with minimal cushioning, they can actually harm themselves by what are called pressure sores. Our kayak seat had to make sure it had the necessary cushioning to ensure that this does not happen.
This has led us to our final product, the Pneumatic Accessible Kayak Device, or PAKD for short.
Due to COVID-19, our group was unable to finish the entire product, but the remaining parts to be added are minimal. So how does it work?
PAKD utilizes a super simple lifting mechanism, which is just an inflatable bladder originally part of an air-powered stool stuck inside a cheap cooler bag. The stool was chosen because it's designed to hold human body weight and was approximately the dimensions we needed. The cooler bag was used to ensure a consistent inflated shape, add protection, and act as a safety measure. The bag is smaller than the stool, so it will rip before the stool overinflates, mitigating the explosion risk.
To inflate the bag, a hose is secured onto the nipple of the bladder by a corrosive-resistant glue. The hose is brought out of the kayak where it is blown into using a high-pressure air tank.
This causes the plastic bladder to quickly inflate. In our testing, we used about 100 psi air, although as low as 10 psi would hypothetically work. The portable air tank we intend on using can hold a maximum pressure of 120 psi.
The airbag inflates in just seconds under this pressure, even when much more than 300 pounds is loaded onto it.
The bag reaches a final height of about 10 inches, above the 9-inch lift requirement to reach the top of the kayak hull.
The lifting mechanism was planned to be fastened to the kayak with bolts, nuts, and a plastic plate, but COVID-19 had other ideas.
The PAKD seat itself is based on a lightweight, water-resistant, and strong PVC frame, which was easy to source and build. After using a decision matrix, our group decided this material was ideal for the frame.
The PAKD frame has two lateral supports, a hip support at the bottom which offers lateral support against the side of the kayak, and the top arm supports which are adjustable using pins to fit a number of body types. Both supports are adjustable vertically.
Now, you're probably looking at the device and thinking that looks pretty uncomfortable. That's because, due to COVID-19, much of the cushioning for this device is missing.
For the lateral supports, it was determined by talking directly with the client that pool noodles could be placed over the PVC to add lateral cushioning. These are cheap, easily sourced if it weren't a global pandemic, and are water resistant, making them ideal.
The lumbar support was made by adapting an old office chair back with a waterproof fabric and various brackets to secure it to the frame. This offers a comfortable and ergonomic back support for the kayaker.
On the bottom, we plan to reuse the existing kayak seat as it can strap to the sides of the kayak and lift straight up and down without issue. This would be secured to the lifting mechanism by bolting a plate at the top of the cooler bag to an existing bracket on the bottom of the seat. This idea worked in testing.
At the client meeting, one of the clients said that the existing seat did not offer enough cushioning. This is another reason the cooler bag is beneficial, as it offers a noticeable amount of cushioning to the seat bottom.
The entire seat frame design was essentially modeled around the existing accessible seat Abilities in Motion have. Our group did some research and determined this seat was the Creating Ability Universal Paddling Seat, which has a sticker price of $725 US.
The entire mechanism weighs less than 4 kilograms, which is below the 5 kilogram constraint.
Overall, the finished product, although not implemented, is a success. It meets all of our constraints, satisfies our objectives, and should perform its task if given the opportunity to do so. It is a shame that COVID ruined the end of this project, but we would like to thank Abilities in Motion London and ES 1050 for the opportunity to work on a realistic project.